morning everyone. We are the Group 6 and our project proposal is the multi-purpose hot and cold air ventilation system. I am Diligent Magsido Maog and my part is the methodology and materials and equipment.
So my name is Axel Brian A. Salino. My part is data analysis, conclusion, and recommendation.
And I am Ardaville P. Agosto. My part is procedures and results.
My name is Celeste Diana Navarro, and my part is the introduction and the objectives. Play an important role in regulating temperature and airflow in enclosed spaces, especially in applications such as food processing and storage. The movement of air in this system is primarily driven by convection, where warm air rises due to reduced density and cooler air enters to replace it. This natural process creates continuous cycle of airflow without requiring external force, making it an efficient method for maintaining proper environmental conditions. The main objective of this study is to construct a multi-purpose hot and cold ventilation system that demonstrates heat transfer through convection. Specifically, the study aims to illustrate how air circulates within a closed chamber, observe the movement of warm and cool air, and explain how ventilation systems contribute to temperature control and practical application such as food preservation.
Methodology. The experiment setup consists of closed chambers with two openings, one lower inlet and one upper outlet. A heating bulb is placed inside a chamber to increase the temperature, while a small electric fan is positioned near the lower opening to assist the entry of cooler air. As the air inside the chamber heats up, it rises and exits through the upper outlet, while the cooler air enters through the lower inlet, creating a continuous cycle of airflow driven by convection. You can see here, this is our product image, where it is which you can use as a box, where you can see the upper outlet and the lower inlet, along with the switch, the fan, the heating bulb, and the heating bulb. The cool air enters through the fan, while the heating bulb heats the cool air into hot air. The hot air rises, exits through the upper outlet. This is the materials and equipment that we have used, and its quantity, estimated cost, item, and then total cost. So, cardboard and wooden box, we can use this as a frame for our product. Small electric fan to use as the inlet for the cold air, the heating bulb to heat the cold air, and then the 12-watt charger to power said fan, and then the foil to insulate everything that is inside. Some of the materials, such as a switch, the light bulb holder, and other materials are not listed because those are the recyclable materials or the materials that we have used in our everyday product. We have used those, we have them in our homes, and then we use them in our product.
Okay, let's start with the procedure. The construction process began by preparing the chamber and creating two openings, one at the bottom air entry and another at the top for air exit. The heating bulb was securely installed inside the chamber, while the small electric fan was positioned near the lower opening to assist the flow of cooler air into the system. To measure temperature change, a thermometer was placed at both the lower inlet and the upper outlet of the chamber. After activating the heating bulb and the fan, temperature readings were taken at regular time intervals of 0 minute, 2 minutes, 4, and 6 minutes, and the temperature at both points are carefully recorded. This method allows for a clear comparison between the cooler air entering the system and the warmer air exiting in, providing reliable data to analyze the convection process and airflow behavior within the chamber. So here's the result. The data from group 1 to 5 show a consistent increase in temperature at the upper outlet compared to the lower inlet over time. At 0 minutes, the system was neutral, with minimal temperature difference indicating the little airflow. By 2 minutes, a slight rise in both inlet and outlet temperature suggested the start of convection. The result at 4 minutes, the outlet temperature increased more significantly, showing stronger upward airflow. At 6 minutes, the system reached a hot condition, confirming a continuous and stable convection cycle within the chamber.
So for the data analysis, the results show that the lower inlet temperature stays stable while the upper outlet temperature increases over time. This difference drives airflow in the system. The strongest change happens between 2 and 4 minutes, indicating peak convection active. After 6 minutes, the system begins to stabilize but continues to maintain airflow. Overall, the larger temperature differences result in stronger and sustainable convection. So data analysis, the rate of temperature change determined using the equation R equals the rate of temperature divided by the rate of time, where rate of temperature represents the change in temperature and the rate of time represents the change in time. So as you can see, this is the temperature initial and final temperature of the upper and inner outlet during the experiment. And the last part is the conclusion and recommendation. The study successfully demonstrates that a multi-purpose hot and cold air ventilation system can effectively illustrate convection and airflow behavior. The consistent rise of warm air, the entry of cooler air confirm the relationship between temperature difference and airflow movement. The system proves to be reliable and practical model for understanding heat transfer in both academic and real-life application. Future improvements may include the use of more stable and controllable heating source, enhanced sealing of the chamber to minimize heat loss, and experimentation with different construction materials, adjustment to vent size and placement may further optimize airflow efficiency, while more precise measuring instruments could improve data accuracy. So this concludes our panel project presentation
on multi-purpose hot and cold air ventilation system.
Once again, I am Ardavil P. Agosto.
And I am Marcel Brian A. Salino.
My name is Celeste Diana Navarro, and
And I am Legend Michael C. Dumao. We are
The Group 6.